Hello everyone. This video will show how to sketch the graph of tangent function. Now let's go over this example. So we're given f of x equals tangent of 1/4 x. The first step that we need to do is to determine the parameters a, b, c, and d. So our a, or the stretch factor, is the value before the tangent that is invisible 1. Our b is the value before the x, and that is 1/4. Our c is the value after the x, and that is 0. Our d is the value after the parentheses, and it's not there, so that's a 0. Now let's move on and determine the equation of the midline. The equation of the midline is y equals d. In this case here, our d value is 0, so that is y equals 0 is the equation of our midline. Now let's determine the phase shift. To determine the phase shift, whatever is inside the parentheses, we equal that to 0 and we solve for x. And so I'm going to show the work up here. So what I would do is I will multiply 4/1 to each side to solve for x by itself. Now we remember that this value that we have here is the x coordinate of the center crossing. This center crossing is the point located in the middle between the two vertical asymptotes of a tangent function. Now let's determine the period. The period of a tangent function is pi over b. In this case right here, we have a pi and then that's over b, which is 1/4. So we have a complex fraction right here. So we have pi over 1, that's the numerator, times flip the denominator, that's 4/1. This gives us 4 pi is our period. Now let's determine the two vertical asymptotes for one period of a tangent function. We're going to start with the left vertical asymptote. That means this is the vertical asymptote that is located to the left of the center crossing. The formula for the left vertical asymptote is x equals the coordinate or the x coordinate of the center crossing, this one right here. We're going to subtract it by half of the period. So in this case right here, our center crossing is at 0 minus half of the period. The period is 4 pi. So half of 4 pi, so that's 4 pi over 2. This gives us a negative 2 pi. Now let's determine the right vertical asymptote. So this right vertical asymptote is the asymptote that is located to the right of the center crossing. And the formula for this would be x equals the x coordinate of the center crossing plus half of the period. So we're going to plug in the values. So the equation of the right vertical asymptote is x equals 2 pi. Now we're ready to sketch the graph of this function. It says here that our midline is located on y equals 0. So I'm going to go ahead and draw that midline up here. Our center crossing is at x equals 0. So it's going to sit here. It also says here that our left vertical asymptote is negative 2 pi. So this is negative 2 pi right here. And our right vertical asymptote is at positive 2 pi. So looking at this represents as our center crossing. This represents as our left vertical asymptote. This is the right vertical asymptote. So I'm going to go ahead and draw the two vertical asymptotes for this graph. Now let's determine the other 2 points of a tangent graph. So it's going to sit here and it's going to sit here. So we're going to determine the values for each of these. To do this, we are going to add a certain value to the leftmost vertical asymptote, a constant value until we get all these labeled. So I'm going to go ahead and show the work down here. That value that we're going to add each time is 1/4 of the period. The reason why it's 1/4 because if you notice, there are 4 more dots that we need to determine. 1, 2, 3, 4. So that is the reason why we use 1/4 of the period. So in this case right here, our period is 4 pi. So I'm going to go ahead and say 1/4 of 4 pi would be, cross out the 4 and 4. So we are going to add pi each time. So what we do now is from negative 2 pi plus 1 pi is negative pi. So the coordinate for this is negative pi. Negative pi plus pi is a 0, which is actually on the point of origin. And then we have 0 plus pi is 1 pi. And 1 pi plus pi is 2 pi. You can add more dots going to the right by adding pi, or you can subtract pi and get all the values to the left. But for now, we're only drawing one cycle of the tangent graph. So we go ahead and determine the next point using the stretch factor. Since this is a positive graph, the right end of our tangent graph is going to go towards the right side. So we go ahead and go pi step to the right. And then we will use the A value to determine the next dot. So we go quarter step of the period to the right, and then we go up 1. So this is where the next dot is going to sit, and we can go ahead and draw the tangent graph. On the other side, we go quarter of the period to the left, and then we go down 1. So this is where the next dot is. Again, the 1 that we have here is based from the stretch factor. So we're going to connect these dots together to form the other end of the tangent graph. So this is one period sketch of this function that we have right there. Now, we remember that we can have more of these to the left and more of these periods to the right. But for now, we're drawing one cycle of this function up there. So that is how we sketch the graph of tangent function.